All right, let's talk about something that's quietly unfolding in hospitals all over the world. It's not a virus, but it's a new kind of threat. It's a bacterium that has basically learned all of our best moves and has turned itself into a nearly invisible, incredibly dangerous superbug. And this isn't some far-off, maybe one-day problem. This number right here, 42%, that is the mortality rate for people who get this superbug in their bloodstream. It's a shocking number, and it tells you right away that the stakes here are literally life and death. So what in the world is this thing? Well, the World Health Organization is already sounding the alarm. This is happening right now. They've officially reported a growing number of cases of something called carbapenem-resistant hypervirulent Klebsiella pneumonia. Yeah, I know, it's a mouthful, but we're going to break down what every part of that scary name actually means. To really get what this superbug is all about, you have to understand that it's a mashup, a terrifying combination of two very different, very dangerous abilities. You know, it's kind of like if a master assassin and an indestructible tank decided to team up. Let's look at what those two powers are. So on one hand, you've got hypervirulence. That's the bacteria's raw power. It's the ability to cause really severe invasive infections. We're talking things like liver abscesses, meningitis, even in people who are young and perfectly healthy. Then, on the other hand, you have carbapenem resistance. Now, carbapenems, those are the big guns. They're our most powerful, last resort antibiotics. And resistance means this bug just eats them for breakfast. For a long time, these two nasty traits lived in separate bacterial strains. The absolute nightmare scenario, which is now reality, is them getting together in one bug. So the big question is, how? How on earth did one little bacterium get both of these devastating superpowers? Well, the answer lies in a tiny piece of genetic hardware that acts as the superbug's secret weapon. And here it is. It's called a plasmid. Probably the easiest way to think about it is like a USB stick for bacteria. It's this small, separate loop of DNA that can carry all kinds of handy, and in this case, incredibly dangerous genetic software. And here's the crucial part. Bacteria can copy these plasmids and just hand them off to each other. And this shows you exactly how it goes down. So you start with a hypervirulent bacterium. That's the one that's really good at making people sick. It then just happens to bump into a different drug-resistant bacterium that's carrying one of these resistance plasmids. Through this amazing process, the plasmid gets copied and then transferred over. And what you're left with is the final product, a single superbacterium that is both ferociously aggressive and bulletproof against our best medicines. But believe it or not, the story gets even crazier. As if being super aggressive and immune to antibiotics wasn't enough, this new superbug has evolved a kind of camouflage, a way to hide in plain sight, making it incredibly hard for doctors to even know it's there. See, for a long time, the really nasty hypervirulent strains had this one obvious tell. They were goopy. The technical term is hypermucoviscosity. It meant that if you took a sample in the lab and touched it with a loop, it would form this long, sticky string. This super simple string test was a reliable, low-tech way for labs to flag the really dangerous strains for doctors. But that's not the case anymore. And this right here is the plot twist. What scientists discovered is that the very same plasmid that gives the bacteria its drug resistance can also make it lose that sticky, goopy coating. So now, these strains pass the string test. They look totally normal, like any other less dangerous bacteria. But they're not. They're just as deadly. They've become a true stealth threat. So let's look at what this means in a real hospital. This data is from a study in Shanghai, and honestly, it's pretty sobering. Take a look at these numbers. Out of 16 of these superbugs found, 100% of them were resistant to our frontline antibiotics. But here's the kicker. They were also 100% resistant to imipenem and meropenem, two of our most powerful last line of defense carbapenem drugs. These are the ones we absolutely count on when nothing else is working. That same study found something else too. Not all of these new superbugs are created equal. The most common strain they found, called ST11, had a 50% mortality rate, which is already just awful. But then there were these other two strains, ST23 and ST86. Their mortality rate was 100%. Every single patient infected with those strains died. It just shows you how unpredictable and extremely dangerous this is.
Okay, so we've laid out the threat. It's serious, it's evolving, and it's scary. But here's the good news. Science is not just sitting on the sidelines. Let's take a look at how we're fighting back in this constant evolutionary arms race.
There's some really incredible innovation happening. We've got new antibiotic combinations specifically designed to outsmart resistance. There's phage therapy, which is amazing. It basically uses viruses that are natural-born killers of bacteria to hunt them down for us. And then there are things like Trojan horse antibiotics. They work by tricking the bacteria into letting them inside by latching onto iron, something the bacteria desperately needs. And beyond that, you've got scientists exploring brand new frontiers with things like nanoparticles and antimicrobial peptides.
So why does a stealth bug evolving in a hospital thousands of miles away matter to you and me? Well, because what happens in the hospital, it never, ever stays in the hospital.
This is what's known as a One Health problem. It means it's all connected. These exact same bacteria carrying the same resistance genes have been found in the soil, in our water, in the meat we buy at the store, and in farm animals. So if we really want to get this under control, we have to think bigger than just hospitals. We need a coordinated effort that includes agriculture, our food supply, and environmental management. And that kind of brings us to the final big question. Every single time we come up with a brilliant new drug, bacteria begin the slow, relentless process of evolving a way to beat it. Our incredible ingenuity is in a constant battle against billions of years of microbial evolution. So as we race to stay one step ahead, you have to wonder, are we creating permanent solutions or are we just buying ourselves a little more time?